Thunderstorms are violent and fascinating phenomena, shaped by invisible forces. But what lies behind this celestial fury? How do physics and mathematics explain their formation? Let's journey into the heart of a storm and uncover its secrets. It all begins with the sun heating the ground. The warmed air becomes less dense and rises. As it ascends, it cools and condenses into clouds, forming the first signs of a thunderstorm. But this process is governed by precise physical laws. Thunderstorms don't just rise, they interact with prevailing winds. The Earth's rotation influences their trajectory through the Coriolis force. High-altitude winds shear the air columns, potentially giving rise to supercells and even tornadoes. Deep within the cloud, collisions between ice crystals and hailstones generate a charge separation. The upper part of the cloud becomes positively charged, while the base accumulates negative charges. When the electric field reaches its critical threshold, a sudden discharge occurs. This is lightning. Thunderstorms are unpredictable in the long term. With advanced weather models, we can simulate their evolution using supercomputers. However, these systems are highly sensitive to initial conditions, as Edward Lorenz demonstrated with the butterfly effect. A tiny variation can drastically alter the outcome of a storm. Thunderstorms are nature's masterpieces, shaped by invisible forces. Each flash of lightning reminds us of the delicate balance between order and chaos. But if we understood these phenomena even better, could we one day predict or even control the weather? Thunderstorms are nature's masterpieces, shaped by invisible forces. Each flash of lightning reminds us of the delicate balance between order and chaos. But if we understood these phenomena even better, could we one day predict or even control the weather?